Prove that sine squared x all over 1 plus cos x plus sine squared x all over 1 minus cos x is identical to 2. That means the left hand side is the same as 2. We take solution. For us to easily prove this, it would be good if we make use of the left hand side, because the left hand side is not highly factorized. Taking the left hand side, we can prove the right hand side. Sine squared x all over 1 plus cos x plus sine squared x all over 1 minus cos x. LCM of the denominators is simply, we're going to take the product of 1 plus cos x and 1 minus cos x. 1 plus cos x times 1 minus cos x. 1 plus cos x times 1 minus cos x divided by 1 plus cos x. 1 plus cos x will strike off 1 plus cos x. We'll be left with 1 minus cos x. 1 minus cos x times sine squared x. This will give us 1 minus cos x times sine squared x plus, we take 1 plus cos x times 1 minus cos x divided by 1 minus cos x. 1 minus cos x will strike off 1 minus cos x. We'll be left with 1 plus cos x times sine squared x. This will give us 1 plus cos x times sine squared x. This will simply be equal to, we are going to expand the brackets at the numerator and the brackets at the denominator. One times sine squared x gives us sine squared x. Negative cos x times sine squared x gives us negative cos x sine squared x. Plus 1 times sine squared x gives us sine squared x plus cos x times sine squared x gives us plus cos x sine squared x. All over, we have to expand the brackets at the denominator. 1 times 1 gives us 1. 1 times negative cos x gives us negative cos x plus cos x times 1 gives us plus cos x. Cos x times negative cos x gives us negative cos squared x. You can see that this denominator is the factorization of a difference of two squares. Next, we have to simplify the numerator and the denominator. At the numerator, sine squared x plus sine squared x gives us 2 sine squared x. Negative cos x sine squared x plus cos x sine squared x. You see that this and this will go to 0. All over at the denominator, negative cos x plus cos x, this and this will go to 0. We'll be left with 1 minus cos squared x. The denominator 1 minus cos squared x is the same as sine squared x. Remember, for any angle x, sine squared x plus cos squared x is equal to 1. From this identity, if we make sine squared x the subject of formula, this will give us sine squared x to be equal to 1 minus cos squared x. When cos squared x is transferred to the right, it becomes negative. Take note of this. This will be equal to 2 sine squared x all over 1 minus cos squared x, which is sine squared x. We have to divide sine squared x divided by sine squared x. This and this will strike off. We'll be left with 2, which is what we have to prove. We are done with the solution of this question. If in case you have any worries, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.